we have the Maclaurin expansion. Maclaurin expansion formula is f of x is equal to f of 0 plus f of I. I means differentiation, okay? I means differentiation, f of 0 x plus f of second time differentiation 0 x square by 2 factorial plus f of third time differentiation x cube by 3 factorial. So normally we have to find up to the 3 terms, okay? So now we have here f of x is equal to e power of sin inverse of x, okay? So we suppose f of x is equal to y, okay? So y is equal to e power of sin minus 1 x, okay? I have supposed f of x is equal to y. So this means y, and f means it is the differentiation, okay? That means here y1 is equal to f I of 0, okay? So and here this means y2, and here we can write this as y3, okay? So remember that. Now here I have done this. So here if we put value 0, that is, so here we have to put x is equal to 0, that is we have to put the value 0 into the x. So if we put 0 in sin inverse x, that is 0, it becomes 0, and e power of 0 means 1, okay? So we can write this as 1. So differentiate it with respect to x, okay? So we get y1 means we have differentiated it one time, okay, is equal to, so if we differentiate e power of sin x, so it becomes so here it is the rough, you don't need to write this. So d e power of sin inverse x by dx is equal to d e power of sin inverse x by d sin inverse x into d sin inverse x by dx. So it is as it is, e power of sin x minus x, and the formula for this is 1 by root under 1 minus x square, okay? This is the formula. Now we can write e power of sin inverse x by 1 minus x square root under, okay? You can see we have e power of sin x is equal to y, so we can write this as y by 1 minus x square, okay? So here is y1. So y1 of 0 means, so if we put here it becomes y of 0 by 1 minus 0 square, okay? So we can write this as, so y of 0 is 1, okay? And here is 0, it becomes 1. So y1 of 0 is 1, okay? So again we have to differentiate this term with respect to x, okay? So differentiate y1 with respect to x, okay? So it becomes y1 becomes y2, and here we have to differentiate this term. We have to apply the quotient rule. That means suppose here we have du by v, means it becomes v and du minus u dv by v square. So this is the formula for quotient rule, okay? So now here we apply the term, that is, so by applying this type of formula, here we obtain 1 minus x square root under dot. If we differentiate y, it becomes y1 minus, and here y is as it is, and if we differentiate this term, it becomes minus x by root under 1 minus x square, okay? So how we obtain this? So we have obtained this root under 1 minus x square with respect to x, okay? So here we can differentiate like this. We can write this as 1 minus x square 1 by 2, as you know, we can write root under x is equal to x 1 by 2, okay? So we have written this form into like this with respect to dx. So this can be written as 1 minus x square 1 by 2 by d 1 minus x square into d 1 minus x square by dx, okay? So it means we have applied the formula. So 1 by 2 1 minus x square 1 by 2 minus 1 into, so the differentiation of this is d1 is 0, and here it becomes minus 2x, okay? So here we have this and this cancel out, so here it becomes minus x and 1 minus x square minus 1 by 2. So we can write this as minus x by root under 1 minus x square, okay? In this way we have obtained this term. Now we can write this as, so we have written, so after differentiation here we have divided by b square, means that is 1 minus x, so 1 minus x square, okay? So root under 1 minus x square is only 1 minus x square, okay? So after this, so here you can see here we have y1. So but in the order we have obtained y1 is equal to y by root under 1 minus x square, okay? We have obtained this term. So now to cancel out 1 minus x square root under term, so we perform, so here we have y by 1 minus x square into, so, and here we have 1 minus x square, and here minus plus, and here we know y by root under 1 minus x square is equal to 1, okay? Sorry, y1. So we can write this as y1, and here is as it is, okay? So now divided by 1 minus x square. So this and this cancel out, and here remains y, and y plus x y1 by 1 minus x square. So that means y2 of 0. So it becomes y of 0 plus x, that is x means, suppose x is 0, and y1 of 0 by 1 minus 0 square. Of 0 means 1, and it becomes 0 by 0 into 1, my 1 minus 0 is equal to 1, okay? So we obtain y2 of 0 is equal to 1. So now again we have to differentiate this term. Okay, so differentiate y2 with respect to x, then we obtain, so if we differentiate this term, that is y2, so here y2 becomes y3, and using same this quotient formula, here it becomes 1 minus x square, and the differentiation of y is y1 plus, and here we have to apply multiplication, so it becomes, if we differentiate y1 it becomes y2, and if we differentiate x it becomes y1. Okay, so now minus y plus x y1, and if we differentiate 1 minus x square it becomes minus 2x. Okay, we have applied this formula, okay, for quotient rule, divided by, so here it is, and we have to, that is e square, it becomes 1 minus x square and e square. Okay, so now we can write this as, so here 1 minus x square, and here is y1 2y1 plus x y2, and here it is minus sign, it becomes plus, and 2x y plus x y1 divided by 1 minus x square. Okay, so for y3 of 0, so for y3 of 0 we have, so 1 minus 0 square, 2y1 of 0 plus 0 into y2 of 0 plus 2 into 0 y of 0 plus 0 into y1 of 0. Okay, divided by 1 minus 0 square. So it becomes, here it is 1, it becomes 1, and here 2y1 of 0, that's y1 of 0 means 1. Okay, we have obtained this term earlier, so into 1 it becomes 0 plus it becomes 0. Okay, so here it is, so 1, so we obtain 2, so y3 of 0, so y3 of 0 is 2. Okay, so we have obtained this term. Now after this as in the equation 1, that is we have the ordinary equation, that is f of x is equal to f of 0 plus f of dash, that is I of 0 x plus f of double I 0 x square by 2 factorial plus f of triple I of 0 x cube by 3 factorial plus, so this is need to write this formula again. So here we have, as you know, we have, suppose f of x is equal to y, so it means y of 0, and this means y1 of 0, and this term y1 y2 of 0, and this term y3 of 0. So it was, so this equation becomes, equation 1 becomes, we have suppose ordinary equation is 1. Okay, so f of x is equal to, so here we have obtained y of 0 means 1, and here we have obtained f of y1 of 0 means 1, and here it is x plus this also 1 dot x square by 2 factorial plus, and we have obtained this value 2 dot x cube by 3 factorial plus. So as you know, f of x is equal to e power of sin inverse x is equal to, we can write it as x plus x square by 2 factorial 2x cube by 3 factorial plus, so this is the required expansion. Okay.